everyone. Tonight we're going to learn about the mean absolute deviation, also known as the MAD. Now this topic is weird. Okay? A lot of people freak out because it's different, but I promise you it's not so bad if you just stick with me. Okay, so you know how in class you like to stop me in the middle of a question and tell me you have no idea what I'm talking about? Hear me out. Let me get through an entire problem. Okay, maybe just watch it the first time and then go through and take notes the second time and even maybe rewind and watch a third. Okay, I promise you will get it, and we're going to do 2 days of practice with this rather than just one. So I promise you'll be okay. First, a couple of definitions. Okay, the measure of variation is the average distance between each data value and the mean. Okay, in other words, this is just measuring how spread out the data is. And that's the whole point of the MAD. Okay, the mean absolute deviation is trying to measure how spread out the data is. Okay, and that helps us with our deviation here. That's used to describe the distribution of data. Okay, so 3 steps for finding the MAD. First, we find the mean, okay, which you know is the average, and you know how to do that. Then you find the distance of each value from the mean. And then we find the average or the mean of those distances. Okay, so we're just going to jump right in. I think it'll make a lot more sense. Okay, so we've been given the set of data. Okay, we want to find the mean deviations. We have 3, 6, 6, 7, 8, 11, 15, and 16. Okay, in order to find the mean or the average of these values, we have to add them all up and divide by 1, 2, 3, 4, 5, 6, 7, 8 values. Okay, so when we add those up, we should be getting 72. We will divide by 8, and we get an average or a mean of 9. And now what we do is we take our list of data, and that goes on this side of our t-chart. Okay, that's our values or our numbers. Okay, and then what we want to do is figure out the distance from the mean. Okay, so how far away from 9 is 3? How many spaces? Okay, well, 3 is 6 spaces away from 9. How many spaces is 6? 3 spaces. And the other 6 will also be 3 spaces away. 7 is 2 spaces away from 9. 8 is 1 space away from 9. 11 is 2 spaces away from 9. 15 is 6 spaces away from 9. And 16 is 7 spaces away from 9. Okay, and that's what this picture here is measuring for you. Okay, if you put your average right in the middle, your mean, you can measure the spaces or the distance from that value. Okay, the next thing we want to do, step 3, is find the average of these distances. So I'm going to take them, I'm going to add them up. Okay, when we add 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7, we get 30. Okay, and I'm going to divide by 8 because there are 8 values there. 30 divided by 8 is 3.75. Okay, so what we know is that the mean is 9 and the mean deviation is 3.75. Okay, again, that word deviation, okay, it tells you how far away from the mean you are, how spread out you are. Okay, so what we know, okay, what we notice is that in general, the data is 3.75 spaces away from the mean, okay, or the average, which was 9. Okay, and this tells us, okay, because 3.75 is a pretty small number, that means that our data is close together. Okay, it's not super spread out. Okay, and if you look at this diagram, if you just look at the values in general, okay, they're a little spread out, but not too bad. Okay, pretty close together. Again, feel free to pause, rewind, and rewatch, and then move on to the next page where we're going to do another example together. Okay, here we go. A booklet has 12 pages with the following number of words on each page. 271, 354, 296, 301, 333, 326, 385, 298, 327, 316, 287, 314. What is the mean deviation of the number of words? Okay, so we start by adding up these values. And you should get 3,708 divided by 12 because there are 12 values here to represent those 12 pages. And when you divide, we get an average or a mean of 309. Okay, so down below, when I take each one of these values and I put it into the chart, I want to know the distance away from the average, okay, away from 309. Okay. Now if I'm trying to figure out how far 271 is from 309, I'm going to subtract. Okay, I'm going to do 309 minus 271, and that's going to tell me my difference or my distance. Okay, we should get 38 here. Okay, for this one, okay, I'm going to flip-flop the numbers, put the larger number first. I'm just going to do 354 minus 309. Again, it's going to tell me the distance between the two values. Okay, we get 45, 13, 8, 24, 17, 24, 11, 18, 7, 22, and 5. Okay, so those are just finding distances. Okay, and then we want to average the distances. Okay, so I'm going to take all of these and I'm going to add them up. Okay, and we get 232, and I will divide by the number of numbers, which was 12, and we'll get 19.33. So the MAD, the mean absolute deviation, is 19.33. Okay, and because that's larger than our last example, okay, we know that this data is a little bit more spread out. And if you look at the values, okay, we go from 271, let's see, to the low 300s, okay, and then to the mid 300s. So they are relatively spread out. Not terrible, okay, not crazy, but this tells us that the data is more spread out. Okay, pause, rewind, rewatch, and then when you're ready, move on to example 2. Okay, this one I'd like you to do on your own. I just want to explain one thing. Okay, a lot of times students get confused by these percent signs. You can really ignore them if you want. Okay, the only reason the percent is there is because these are the scores they got in their exam. Okay, so someone got a 23%, someone got a 37%, a 45%, et cetera, et cetera. Okay, if you just want to say, okay, they got a 23, a 37, a 45, a 49, no big deal. Okay, for the mean, you're going to add them up and divide just like you always do. Good luck. We'll talk tomorrow.